Welcome to part 6 of a 6-part series where we will explore using the Intel Quartus software scripting capabilities. I will give a brief overview of the Intel Quartus software scripting capabilities. The Intel Quartus software has extensive command line support. It has separate executables for each step of the compilation and for certain tools and utilities. There are more than 15 executables. Each executable has options for common settings and procedures. You can use the executables in batch files, shell scripts, makefiles, or any other scripting or batch language of your choice. Here is a typical design flow using the Intel Quartus software with the command line executables in bold. The executables can each be run by themselves with the only requirement being that there is a valid Intel Quartus software project. To understand more about the command line executables that are available, you can launch the Intel Quartus software command line and Tickle API help by running Quartus_sh-kelp from a command prompt. Doing so will launch the GUI that you see here on the slide. This GUI will give help information on the executables listed. You could also go into the bin64 installation directory and launch the executables on the command prompt to get more information as well. In addition to the command line executables, the key help also gives information about the Tickle packages that come with the Intel Quartus software. The Tickle functions can call up the executables by themselves with the functions that are available. The help gives information about the packages and the functions and what arguments the functions take. For example, the flow package highlighted here contains the execute flow function, which calls up the command line Quartus_fit executable. The executables that are run are the same executables that are run through the GUI. You can see all the different steps in the fitter by going to the processing pull-down menu and selecting Start. All of the stages of the fitter are shown there in addition to other executables that you can use to manipulate the netlist that is produced by the fitter. The basic fitter flow commands are recorded in the flow.rpt file to help you get started on scripting your flow. Since the Intel Quartus software supports Tickle scripting, you have available to you all the resources that come with Tickle. The command line executables can be controlled through Tickle, and your scripts can be launched directly the Intel Quartus software shell by using the dashed option along with the name of the Tickle script. You can launch an interactive Tickle shell running from a command prompt Quartus_sh-s. You can run Tickle commands in a Tickle console in the GUI itself, or you can run your Tickle scripts from the Tools pull-down menu and selecting Tickle scripts. You can see which Tickle packages get automatically loaded when you add the --tickle eval help option with the command line executable. The resulting information will be all the packages that are loaded, so if there are other Tickle packages that you need loaded, you can use the load package command along with the library name, Quartus in this case, and the package name. At that point, you will have all the functions available to you that are in the newly loaded package. One package in particular is the flow package. The flow package comes loaded when you launch the Quartus shell. The flow package includes a number of functions, one of which is the execute module function. This function can access the synthesis command line tool by using the -tool syn option. The fitter is also accessible, and all stages of the fitter can be run by passing in the fit option to the tool argument. Since the entire Tickle language is available to use, you can get a little more creative with scripting your FPGA flow through the fitter, as shown in example 2. The settings file or QSF contains all assignments for your project and is Tickle base. Assignments can be pin locations or optimization technique applied to specific entities or nodes. They can also be project-wide switch, such as fitter effort, whether the fitter will generate output netlists and so forth. One thing to note, timing constraints are located in the SDC file and not the CAS file. If you're using command line executables to create a new project, you must use a Tickle script to apply assignments to the project. These assignments will be automatically written into the QSF file. You can also issue the commands to create a new project in the same Tickle script that applies the assignments. Ultimately, you can also directly create a project by creating a QPF, the Quartus project file, and the QSF file. Here are some ways you can generate a Tickle script with assignments. For an existing project, you can generate a Tickle script for the project through a menu item in the Intel Quartus software GUI under the project menu. The generated script includes all the assignments necessary to recreate the project. You can also create a Tickle script by hand, which is pretty simple to do this, though you need to be familiar with the assignment syntax. Finally, you can also copy Tickle statements from an existing project's QSF. The QSF is Tickle base and as such, can include Tickle commands and even source Tickle scripts to run. For example, if you wish to have your pin location assignments in a separate file, You can source that file in the TSS so that the assignments can be made. On this slide, you see some global assignments that allow various tickle scripts to be run depending on what part of the place and route flow is happening. The pre-flow script file assignment will run the assigned tickle script before synthesis. The post-module script file will run the script after each compile step, and the post-flow script file will run the tickle script after the fitter finishes. Let's walk through an example on how to use command line executables to create and compile a project. We have all the source files for the project. We'll assume we know all the assignments for the project. So we'll create a file that has all the settings and a script to compile the project. Here's the tickle script that creates the project and applies the settings and assignments. The project new command creates the project with a project name that matches the name of the top-level design entity, in this case Filtref. Next, we use a series of set global assignment commands to set the device family and part name, followed by the top-level design file. Here, the top-level design file is filtref.bdf or block design file, which is the format of a schematic design file. After that, you'll see the pin location assignments. Lastly, we use the project close command to close the project. This script is short, but for your own designs, your scripts will likely be similar, but much longer. This is a shell script that would create the project by sourcing the setup proj.tickle file from the previous slide and runs the compilation flow. The first line runs the Quartus_sh command line shell with the setup proj.tickle as an argument to set up the assignments for the project. We then run the synthesis executable Quartus syn with the option to optimize for resource usage. After that, place and route is performed on the netlist along with the assembler to create a programming file. Finally, we run the static analyzer to generate the default timing files. One thing to note: if you have multiple revisions in your project, you can optionally use the -c option to specify the revision to compile. Alternatively, instead of running each of the individual command line executables separately to compile a design, we can also use the Quartus_sh executable with the -flow compile option to run the entire compilation process in one command. This is equivalent to pressing the Start Compilation button in the Intel Quartus software GUI toolbar, and it will run the synthesis engine, fitter, assembler, and timing analyzer. There are also other flows available such as implement, finalize, and recompile. Check the documentation or use the help option of the command for more information on those. After running the scripts or commands in the previous slides, you end up with completely compiled design along with POF and SOF programming files, report files for each stage of the compile process, and the timing analysis report files. Sometimes if you're having trouble meeting timing or achieving fit for a particular compile, it may be useful to try different seeds. A seeds is a number that represent an initial layout for the place and route engine. If you're trying multiple seeds, it may be useful to do that in a script. In this example, I've written a shell script to run the fitter 5 times, and saves the results to separate directories. First, I use the Quartus syn function to run synthesis. Then I run a for loop with 5 different Cs with the seed number being the loop index. When each fitter run is complete, I copy the files into a separate directory based on the seed number. We now have an understanding of the Intel Quartus software scripting capabilities. Intel provides multiple avenues in which to learn about Intel FPGA products. There is the Intel FPGA YouTube channel, which contains 5-minute quick videos along with longer, more in-depth training videos. There is the Intel FPGA training website, where you can access e-learning courses made up of narrated slides presented in an interactive player, some courses with labs and demos. Lastly, you can also enroll in a live, instructor-led course presented either in person, at an office local to you, or virtually over the web. All instructor-led courses have hands-on labs exercises to practice the concepts you learn. If you need more assistance, Intel FPGA provides many self-help resources for you to access. For example, there are web pages called landing pages dedicated to specific FPGA technology like and high-speed interfaces. You can also view and post questions to the community forum, which is monitored by skilled Intel FPGA application engineers. The Intel FPGA training team is always looking to improve our material and welcome any feedback you may have. Please email fpgatraining@intel.com with any of your thoughts or comments. Thank you for listening to Part 6 of the series, Intel Quartus Software Introduction to Scripting. Check out our other 5 parts in this learning series.